Here's another example of translating exponential functions. Y equals a negative 4 to the x plus 2. I'm going to begin with the parent function of y equals 4 to the x. I have the associated ordered pairs that go with that function, and I've graphed that function. The domain of this given function is x is all real numbers, and y is greater than 0 with an asymptote at 0. Now, let's perform the translation. I need to reflect each ordered pair, and then translate those ordered pairs up 2. So I'll have an asymptote at a positive 2. Let's begin by starting at a negative 2. The outcome is 1/16. 1/16 times a negative 1 is a negative 1/16, and then up 2, which would give me 1, 2. Next, our ordered pair is a negative 1. The outcome is 1/4. At 1/4, I'm going to go multiplying by a negative 1, which is a negative 1/4, and then up 2. 1, 2. Next is at 0. 0, I have an outcome of 1. Multiplying by negative 1 gives me a negative 1, but then I'm going to count up 1, 2. Next, at 1/4, I'm going to multiply by a negative 1, which gives me a negative 4. But I'm going to translate that up 2 units. And my last one I have at 2/16. Multiplying by a negative is going to give me 2 negative 16, which is approximated down here. And then I'm going to move it up 2 units. Then I'm going to connect those points. And my red function is going to be my new function created by translating the parent function with an asymptote at 2, with a domain of all real numbers and a range where y is less than 2. Here's another example of translating exponential functions. I'm going to begin by plotting the parent function, which is y equals 0.2 to the x. Here's the associated ordered pairs and the graph. As you can see, 0.2, the b value is between 0 and 1, therefore it is a decay. And what I'm going to do is move this function to the left 3 units because of the plus 3, and down 4 units. So let's begin with my negative 1. I don't want to plot negative 2 because that's at 25. So let's begin at negative 1. At a negative 1, 5, I'm going to move that to the left 3 units, 1, 2, 3, and then I'm going to move it down 4. 1, 2, 3, 4. So it was at a negative 1, 5, and I've translated it 3 units to the left and down 4 units. Next, I have a 0, 1. At 0, 1, I'm going to move it 3 units left, 1, 2, 3, and then down 4 units. 1, 2, 3, 4. At my next ordered pair, I have 1, 0.02, 3 units left, 1, 2, 3, and then down 4 units. 1, 2, 3, 4. And finally, 2 at 0.04, moving that 3 units. 1, 2, 3, and then down 4. 1, 2, 3, 4. And as you can see, I can connect the points. And I will have an asymptote at a -4. My domain, x. X can be all real numbers. And my range, where y is greater than a -4. For my last example, I have y equals a -3 times 4 to the x minus 5 plus 2. I want to begin, before I translate my function, to actually graph my parent function, which is y equals 4 to the x, or b to the x. Here's the associated ordered pairs, and I've graphed my function. I can see it's a growth because b is greater than 1. So let's begin by moving my -2 1/16 ordered pair. So I'm going to have a -2 1/16. I'm going to move that 5 units to the right. 1, 2, 3, 4, 5. Multiply that by a -3 gives me a -3/16. And then add 2 to do a vertical translation. 1, 2. Next, a -1 1/4. So the -1, 5 units to the right. 1, 2, 3, 4, 5. Multiply 1/4 by a -3 gives me a -3/4, and then up 2 units. 1, 2. My next one, I'm going to go to 0, 1. 5 units to the right. 1, 2, 3, 4, 5. Multiply 1 by a -3 gets a -3, and then up 2 units. Next, I have 1, 4. I'm going to translate to the right 5 units. 1, 2, 3, 4, 5. 4 times a -3 is a -12. That's approximating. And then up 2 units. And I can connect my points. And when I plot my asymptote, that's going to be at y equals 2. You can see that because I have +2. My domain, x, can equal all real numbers. And my range, y, is less than 2.